At the 13th Australian Microcap Investment Conference, Hazer Group showcased its groundbreaking hydrogen graphite production technologies. Led by Managing Director Glenn Corrie, the company is driving sustainable energy solutions for a cleaner, greener future.
Ready for some hydrogen? There's a plant, actually, that is the plant. Really wonderful shot of our plant in Perth, which is our fifth very successful scale-up of our technology. And I'll talk about that very shortly. Is that Hazer actually stands for Hydrogen and Zero Emissions Research. That was the vision of the company about 17 years ago, and that is very much the reality of our company today. Simplistically, we're decarbonising gas. So we're removing the carbon out of gas, which is gas makes up about a third of the world's energy consumption today. So a really big part of both developed as well as underdeveloped economies. And we're accelerating with our technology a pathway to clean hydrogen much faster than any available technology and process that is available today because of the fact that we use gas as a feedstock and at scale. The technology is pretty straightforward. Effectively, we take any methane-rich feedstock, LNG, natural gas, wastewater treatment gas, biogas, and we effectively, at temperature, we split it into pure hydrogen and carbon in the form of graphite, a critical mineral, graphite. The X factor of our technology is that we use an iron ore catalyst, and that does a couple of really important things for us. That's the intellectual property on the company. It reduces the temperature of what we call pyrolysis, that decomposition of gas, down to around 800 to 900 degrees. All right. And why is that important? It's important because most of our competitors in this space and the general pyrolysis reaction occurs at around 2000 degrees. So you can automatically see that the cost and the energy required to use Hazer relative to the other technologies available today is significantly lower, sometimes up to half. So a really important factor of our technology. The other aspect of using a catalyst and our particular reactor is that we have graphite as a co-product. Okay, graphite, critical mineral. I heard Martin talk about that earlier. Our graphite is very high purity. I'll talk a little bit more about that. But think of our technology as one technology that serves three very important markets: the hydrogen market, the clean hydrogen market, the critical mineral market through graphite, as well as industry decarbonisation. Right. Zero emissions, by the way, in this. Decomposing methane comes with zero Scope 1 emissions. We use a fluid bed reactor. For those not necessarily familiar with refining technology or metallurgical processes, fluid bed reactors have been around for a very long time. It's one of the secret recipes of Hazer, the fact that we've adopted a proven reactor complex and system and repurposed it to use it in our technology. So if you look at our process, there's not many aspects of our process that is novel, and that means that we can drive out plants for very low cost with a significantly reduced footprint, given that we're adopting technologies as well as standard industry processes to effectively carry out the Hazer process. So with all that, we've got some really important uniquenesses, how we differentiate relative to the competition. We're advanced TRL, technology readiness level is 7 going to 8 on the scale of 9. So we're very advanced. NASA developed that scale a long time ago. So it puts us on the cusp of commercialization of our technology. We're low cost, I'll come to that, very importantly, being low on the cost curve in the hydrogen sector and industry is very important given what you've seen in the news flow. And again, I'll talk about that shortly. Graphite relative to carbon black. If we just go back one, I talked about some of the peers. Some of the peers, pyrolysis generally without the use of a catalyst will throw off carbon black, which is not necessarily a valuable product. Graphite, of course, has multiple applications worldwide as a critical mineral. So graphite, a big part of the value story, proven scalability through the use of that fluid bed reactor. Fluid bed reactors have been seen up to 60 metres in height and 10 to 12 metres in diameter. So very large scales. One of the reasons why some of our commercial customers have chosen Hazer because of our ability to get up to very large industrial scales for large-scale decarbonisation of industry. We plug in, we drop into existing processes and supply chains and infrastructure to ensure that we can provide hydrogen to the customer at its demand center. And that's important because it eliminates the risk of transporting hydrogen, which is not really a technology that's available today, and all the cost and the logistics of effectively transporting a pretty difficult gas. And first mover advantage, I want to talk about some of the customers and what the pipeline looks like beyond that. Moving to the cost picture, really important aspect of our business. We are one of the lowest on the cost curve worldwide, right? So we can deliver hydrogen into North America for $1 a kilogram. You'll hear numbers from green hydrogen in the order of $10, $12, $15, $20 a kilogram. With Hazer's technology, we are significantly well advantaged, driven by a number of key factors: low cost gas feedstocks, fluid bed reactors, the low temperatures, the low energy requirements, which drives out a significantly low cost for hydrogen delivered cost. It's a third of the cost of blue hydrogen, which is SMR plus carbon capture. But importantly, we're optimistic, well, conservatively, we're 6 to 7 times cheaper than green hydrogen. And this is one of the reasons why Fortescue, Woodside, Shell, Origin more recently have pulled away from the green hydrogen space, purely because of the very high cost of producing hydrogen and delivering it to a customer. So very advantaged position, one of the lowest in the cost curve worldwide in terms of technologies. Graphite I spoke about, critical mineral. Graphite I think is number 9 or 10 on the critical mineral list in Australia. I think it's somewhere fairly similar in the US. It is the only critical mineral in the top 10 that Australia and the US do not produce domestically at scale, right? So I think Martin mentioned it. The world, I think, relies on about 80 or 85% of its graphite supply from China. That's a sovereign risk, of course. And Hazer, with its graphite production side of its business, is not just a diversified part of the earnings, but also a critical supply of graphite to the world. It comes with a lot of volume, and this is a very unique product. It's low sulfur, low ash, high thermal electrical conductivity. It fits beautifully into steel making, which I'll come to shortly. Water purification, steel making, I would say thermal energy storage, asphalt, bitumen, a broad range of applications of price points anywhere between sort of $500 to over $1,000 a tonne. So a significant diversified aspect to our business, which is a co-product, but also a very big value kicker for the economics, which I will again refer to shortly. We've got a partnership with Mitsui. They are one of the world's largest traders of commodity and energy products around the world. We've been working with Mitsui for close to 2 years. We've just recently extended that partnership on an evergreen basis year by year. We have had amazing feedback on our graphite from market, in particular, as I've said, from steel makers, anode producers, and others that see the real, not just the low emissions component to the graphite, but also the potential access to large volumes in the future. It's a really exciting partnership. It is a very big partner that is effectively acting in some respects as our marketing agent worldwide for our graphite product. So we're very proud to have them on board. We've been on this journey for 17 years. It is the reason why we're a very advanced technology. We're on the cusp of commercialization. We've scaled it very successfully 5 times, right? So we started this journey back in 2007. Andy Cornijo was one of our founders, very successfully has helped us scale this technology to this level. I'll talk about the plant shortly. As we've got bigger, it's got easier. As you can imagine, with most technology ventures, growing up is easier because you can get access to equipment and materials and so forth, and the supply chain. And this is the final stage in our scale up before we take the technology and market it commercially, all right? And we are walking and chewing gum at the same time because we are technology developing, but we've had very strong demand for the tech as we continue to develop, right? And that is a real, for me, being low cost and having industry validation of your tech are 2 really important components of a technology development strategy. We plug in, so forget trying to move molecules around the world in really difficult ways. The best way to transport hydrogen today is in gas, in LNG or pipeline gas, and cracking it and providing it to the customer at the demand point where they require it. Not producing hydrogen in the Pilbara with solar and other really expensive techniques and putting it on a ship and transmuting it to Singapore and re-cracking it and regassing it and other things. That's complex and it's very high cost. But if you're in markets like Japan, Korea, Taiwan, Singapore, Malaysia, Indonesia, the US, where gases are ready, feedstock and a big part of the energy mix, then using it as the decarbonisation transition to clean hydrogen is a real advantage for the technology. And we're not the only ones talking about it and validating it. We have got some of a rapidly expanding footprint of customers worldwide now picking up the tech. Some of these names will be familiar to you. We've got 4 foundation customers in North America. Fortis BC, which is a utility about twice the size of Origin Energy. In Japan, we've got Chubu Electric, Chiyoda Corp as a partnership. Chubu, for those not familiar, is the world's largest LNG importer. They import about a fifth of the world's LNG with their partner Tokyo Electric, big power generator. Chiyoda builds a lot of big stuff. Close to them is POSCO, again, the world's largest steelmaker outside of China. They're the 6th largest in the world. They have chosen our technology as the preferred technology for their green steel process, right? So that speaks volumes to, and I want to talk a little bit more about steelmaking because it's really where all of our tech comes together. In Europe, ENGIE, a very big gas utility. Mitsui, I spoke about. Hatch and Wood, big engineering firms, big technology developers that are sort of helping us and supporting our technology development. Behind all this is actually 30 plus commercial conversations with big industry, all right? And I can tell you that we are talking with most of the super majors, most of the gas players, many steel makers, utilities, cement groups and others that see the value and the decarbonisation potential of what we do. Most of them are hard to abate sectors. What that means is they're very, very difficult to electrify. And so you need a product like hydrogen to generate the heat. And that is what effectively is required. And of course, doing that with low emissions is critically important for the climate. Yeah, buckle up. This is going to be a pretty interesting ride over the next 12 to 18 months. We've got technical milestones, we've got commercial milestones, we've got corporate milestones, and of course, we've got strategic milestones as well. The CDP has been hitting it out of the park, 100 hours, 240, 360 hours. We've in an extended run at the moment, shooting for the covers. So a lot of really good technology feedback. The technology is de-risked, okay? I'll talk about the CDP shortly, but it is now at a stage where we're optimizing it and ready for commercial deployment. We're shooting for an FID, final investment decision, with our partner in Canada. It'll be our first commercial plant. With technologies, the first is the hardest. You know? And once you've got that, generally, what I've seen at least in my career with technology developments is once you've got the first, it's a watershed moment for others to say, okay, this is a technology that is ready to rock and roll. So we're excited about this project. They are a very big player. They're funded by the government through to FID. We're almost at that point where FEED is almost completed. We're in discussions on the commercial terms. Once you'll see that, you'll actually see the strong underlying value of this technology and that it's a licensing model that throws off a lot of cash when we're in operating mode. Japan, through feasibility, the numbers are great, so that's moving into pre-FID. There's commercial discussions ongoing there. I'd be disappointed, given the pipeline that we are working on, then the depth of it and the quality of it, that we will have more commercial partners signing up this technology. And it is starting, we've seen a big shift in industry away from green hydrogen towards pyrolysis, just because of the cost dynamic and the simplicity and the deliverability and the readiness of it. And that is really, in the last 12 months, we have seen a multiplication of interest in the technology. Mitsui, we've just signed up again for another 12 months plus on an evergreen basis, year by year. it is a really big value kicker for us, and we're very keen to show the market and the investor group that are out there the real quality and the potential value upside for graphite. So again, something to keep an eye on, but it could be something that is a big value contribution to the overall project economics. And corporately, we continue to get more runs on the board. R&D rebates normally come through this time of the year. We spend a lot on R&D, so every dollar we spend, we get 50 cents back, which is fantastic. So our business in some respects, or at least our technology technology development is partly funded. We're in the running for some other grants as well as some other arena milestones at the government level. The market, just pause for a minute and talk about the market. A lot of people don't appreciate how big the hydrogen market is. It is massive. It's valued at $180 billion. It's a big market with a very big problem. Why? Today's TAM, or total addressable market, is about 100 million tonnes per annum. Okay? To put that in context, it's a quarter of the LNG market. But it's actually valued at twice the size of the LNG market. Quarter of the volume, but a very big value. What is it used for? All refiners in the world today use hydrogen to desulfurize crude oil, and every ammonia plant in the world uses it to produce fertilizer and ammonia. Okay, that's the two big industries for hydrogen. The problem with it's a big market. In fact, it's a massive market with a massive problem. All of that, the entire amount of it, is produced with a process called steam methane reforming. Every tonne of hydrogen produced today is associated with 10 tonnes of CO2. It's 10 times the amount of CO2 than it is the amount of hydrogen that's produced. So you can imagine it's actually more of a CO2 production technology than it is a hydrogen production technology, but that's the disruption for Hazer. Why? We use the same feedstock in gas. In fact, I'll just go to the next one because it's nicely laid out here. The middle row is steam methane reforming. Natural gas feedstock, lots of water, 1 tonne of hydrogen, 11 tonnes of CO2, big problem. You normally have to abate or pay for the cost of that CO2. Big carbon intensity, big footprint, all right? Electrolyzers, green hydrogen as referred to, it's chemistry, the molecular bond of water is 7 times stronger than the molecular bond of gas. That's chemistry, you can't change that. It also means that you need 7 times the energy to break it apart. Water and electricity with electrolyzers and green, you get hydrogen, you get lots of oxygen, fine, because it's not damaging to the environment, but you lose a lot of energy and you use a lot of energy, and therefore you need renewable power to do it. Why Hazer is so unique and disruptive is because we use the same feedstock, and the switching cost of us to disrupt today's industry, the dirty hydrogen industry, is we basically bring out 1 tonne of hydrogen and 3 tonnes of graphite with no CO2. Okay, you still with me? Because that's a really important differentiation. We do it at a 1/7 of the energy of green, hence the reason why our costs are a 1/7 of the factor of green, and with a very low carbon footprint. And that is in one page, the reason why Hazer's technology is very disruptive. Commercial demonstration plant, going amazingly. We've been at this for now almost a year, 9 months, 10 months, going well. We've doubled reliability every time we've done it. We're using biogas as a feedstock, so it's producing actually the cleanest form of hydrogen from the dirtiest form of gas. So it's a wonderful demonstration of our tech. Reliability, fantastic, 97% uptimes. The hydrogen conversion factor, or the conversion from gas into hydrogen, is actually very, very high, approaching 98%. Okay, so efficient and reliable is what we need for commercialization. And actually, quite a lot of graphite. In fact, if you want to look at a sample, here it is here. We can play with that later. CDP, almost there in terms of demonstrating the technology and the optimizations for the technology prior to rolling it out. Commercialization, we have 4 foundation customers worldwide, big players as I talked about. We've got first mover advantage in North America, Asia and Europe, and we're hunting around for more in the Middle East as well as in those same jurisdictions. But take credit, some of these players have done 2-3 years of diligence on our technology. They don't just turn up and say, oh, we like your tech and let's plug it in a steel making facility. It's years and years and years of diligence on our technology, data rooms, commercial conversations, and we're really proud of the fact that our tech has stood up to the biggest scrutiny by some of the biggest players in the industry. Watch this project closely. It is approaching an FID next year. That we think is a real inflection point for the company. Money is now flowing from this project. So we've got a license model here that has early revenues coming through from engineering services. We've just received our first 2 payments. So you can start to see that Hazer is growing up as a technology venture, offsetting some of our costs with some engineering services. The next step is the license fees, of course. POSCO, what to say? The world is... Steelmaking and cement make up about 20% of the world's CO2, right? Steelmaking's 8 to 10% of the world's CO2. Big industry, big problem, big players. They need a solution. You hear lots about the switching from the blast furnace to the electric arc furnace. Hazer has been chosen by POSCO to be the preferred technology for their green steel, to provide not just hydrogen, but carbon in the form of graphite for both avenues of steel making. And I'm not a steel expert, but I've learnt a lot in the last 12 months to 2 years. Carbon, believe it or not, is used all over steel making as many, many factors, recarburizer, as a replacement for coking coal, many, many applications. And partly the reason that, POSCO has chosen us because our tech comes together. We use iron ore as a catalyst, we use hydrogen, we produce hydrogen, and we produce graphite. All 3 product streams and feedstocks actually are in the steelmaking process. So beautiful synergies for us. Chubu Electric, a big project in Japan. We're a licensing model. Okay, so we're not building plants. I've got 25 to 30 people sitting in an office developing a technology that is world-class. So we stick to our knitting and we develop the tech. We have a licensing structure, which is a 3 tiers approach. It's pre-FID engineering services, at FID a license fee, and post-FID or final investment decision royalties on product streams. When you look at our cash flows, it's all above the line because we don't spend large licks of capital building plants. So it enables early access to free capital and cash, and we don't need big licks of capital to build plants. We're licensing the tech, and all of our plants today are under licensing agreements. Okay, so let's break apart the economics for those who love the numbers. If you can imagine your POSCO, this is what your cash flows are going to look like. You're going to spend about $200 million on building a very large-scale plant, which is actually quite cheap and affordable. The capital intensities of these are very low because it's mostly industry-standard equipment off the shelf. Remembering our IP is more on the process as opposed to the equipment. They throw off a lot of cash, roughly at 50,000 tonnes per annum, which is equivalent to today's industry standard kit. So the switching and the disruption is easy. They all throw off about 300 million or 400 million Aussie in terms of an NPV. Very difficult to find a climate technology that throws that sort of value off. But more interestingly and importantly, for what does it mean for Hazer? That's the project proponent or owner. Every plant for us through that licensing model brings in around $100 million of NPV in license fees at a 3 to 5% royalty scheme. So I'll let you do the maths, but it doesn't take many of these for Hazer to be a $500 to $1 billion platform. We've already got 4 customers. We have a pipeline of over 25 and 30 customers. And you only need 5 to 10 of these projects worldwide, which would equate to under 1% of the global demand for hydrogen for this to be a very, very large platform. Okay, so that's the sort of scale of the company. And I love the fact that we have a big vision and that we're not there yet, because this is what drives us as a company. We have a vision of being 10 plants in 10 years. We've got 4 big customers already, a deep pipeline, and we're on our way to what I'd call to being a publicly listed unicorn as a company. So that was it. Very happy to take questions. In terms of the highlights, low cost, clean hydrogen technology that's very well advanced. We're commercially ready today, and we co-locate with existing infrastructure and supply chain, so you remove the risk of transporting molecules. We're CapEx light. We don't spend big licks of capital building plants. We leave that to others that are better than us at doing that. Tier 1 global partnerships across strategic markets, validating our tech and providing us with a visibility on commercialization. And of course, we've got the tailwinds of a big industry behind us. Thank you.
Thanks, Glenn. Any questions?
Thank you very much. It seems to me that your plant is going to produce two products, hydrogen and graphite. So you're going to produce hydrogen and graphite. Which is the more important revenue-wise?
Well, very good question. It depends, as you can imagine. Probably the hydrogen, to be fair. We've got more volume of graphite, but if you think about the unit cost and price of the hydrogen will drive the majority of the underlying value. If I was to just sort of break apart, depending, if you say assume $400 a tonne, which we think is conservative for graphite, probably about 20% of the value is graphite. But it changes in markets. It depends on the application. We've seen graphite pricing ranges sort of up over $1,000 a tonne. If you put that into the model, then you start to see the balance shifting towards the graphite. But what's nice about it, it's a diversified earnings base. They're quite different products. One's a solid, one's a gas, different markets, different applications. So we're the only real technology. By the way, this is the world's leading technology in methane pyrolysis. There's a few of us, but there's none this advanced. We're the only one doing it with graphite as opposed to carbon black. That plant you saw in Perth is the second largest plant in Australia, the clean hydrogen plant that's operating today. So it's a really unique aspect of our tech. I look at the graphite as significant upside. We're trying to be conservative on the value, but it's creeping up as we see a lot of feedback from Mitsui and others in terms of the potential applications of it. Yeah.
I have a very similar question. Really, three different value drivers. Could any one of them alone being driving enough value, like if there's a huge carbon price, it would be maybe enough to take just the methane out of the air and have the other byproducts or so?
Very, very astute observation. The number that I showed, if I may just divert for a little bit to kind of answer your question, the $1 a kilogram in the US doesn't actually take into account any of the subsidies that are available in the market. If you're familiar with the US, the Inflation Reduction Act, very supportive towards hydrogen and technologies. Those numbers don't include any benefit. We kind of don't need it because we're so low on the cost curve, but we'll take whatever we can get, of course. Back to your question in terms of the value of each of those products. It depends on the market. We also don't take into account any carbon offset credit. So where you have big markets like, for example, Singapore, where they say you're going to be penalised $100 per tonne for carbon, that's a benefit to our technology, right? Because we're saving money and a cost for an industry that would otherwise pay, $50 million for carbon offset. So that's why you've seen in that pie chart, our revenue streams today are focused on the hydrogen and the production technology side and the production. But there is a third element to it, which is we should also be really taking the royalties around the carbon offset. So that's upside as well. So we're trying, like I say, we're sort of conservative in terms of the tangible value today, but industry is moving to polluter pays, as you know. And that means that there is significant more value upside for us as a technology in terms of that particular strand of the market. Does that help answer the question? Yeah.
I think we've got time for one more question.
I just want to get some clarification on the recarburiser for the steel industry. That is, you're getting natural graphite, is flaky graphite, that's then been refined down and then turned into spheroid graphite. Then it's coated, it becomes coated spheroid graphite. There's essentially three products come out of the ground, after processing.
Yeah. Okay.
Where does this graphite product fit in that product classification as a recarburiser? And is it bricketed or pelletised?
Yeah.
Or is it in a powder form? Because there will be some processing of that.
Yeah, absolutely. So everything you said, I agree with. It's a synthetic graphite. It's got a very small elemental iron component to it because that's the reduction in the reactor. Some may see that as a disadvantage. In steelmaking, that's an advantage. If you've got a carbon product, and carbon's used all over steel as well as a recarburizer, but with a 5% component of elemental iron in there, you've got a yield benefit as well, right? If you're reducing down your carbon with the elemental iron, you're basically increasing your production yield. I'm not an expert on steelmaking, so forgive me for not giving you the details that you need, but there is the reason I mentioned recarburizing in the electric arc furnace, not the blast furnace, by the way, is because that is the new component of steelmaking.
Well, the carbon is used for standardising the quality of the steel.
That's right.
There's other in the pig iron, right, that's then turned into steel.
Yeah.
You add other different minerals into it, like manganese.
That's right.
Or sulphur, or carbon, and carbon is used to make it harder. Okay.
Yeah.
So and that's really like for machine tools and those sort of things.
Yeah.
Right. So there's a stage when you add it into the process.
Yeah.
You don't sprinkle it on the steel. It normally goes into the ingot. And I'm not too sure what they do these days in concast, because concast wasn't used in Australia.
Yeah.
And the same would go for electric arc
That's right.
making, because you lose a lot of chemicals up the chimney.
So
I think we're just running into the
Yeah,
next
so
the next
the
one.
thing is that
It's educational.
I'm looking to see what's the marketable product that you have in the steel industry, because you've made a big issue of the potential for steelmaking.
Yeah, so a very good question. We can talk about it offline. POSCO, which is doing this for real, blast furnace and the electric arc furnace, actually sees the Hazer process more applicable to the carbon side of their business as opposed to the hydrogen. The hydrogen they can get for the DRI from anywhere, but it's more the carbon and the elemental iron component of it which they see as the most value.
Hazer Group is setting a benchmark in sustainability, transforming renewable energy with its innovative technology. Focused on real-world impact, the company is leading the transition to a cleaner tomorrow.